Welcome to Study Loop.
Okay, so since we have three unknowns, so we need three equations to solve this problem. So we have three batteries and then they are connected to a bunch of resistors. And we need to apply Kirchhoff's law to solve this complicated circuit. So there are two things that we should do while using Kirchhoff's law. First, we'll apply junction rule and then we'll apply loop rule to solve for it. Now we see that we have two junctions over here. One is around here and one is on the right. Now, if we consider one of the junctions, let's consider the one on the right. We see that I2 and I3 they are going towards the junction and I1 is going out of that. So that means I1 should be equal to I3, I3 plus I2, and that gives us a relation between our three currents using junction rule. Now we divide our two loops and name it top and bottom. So for the top loop, let's consider the direction to be anti-clockwise or counterclockwise. And if we do so and start with the battery in the middle, we see that it goes from negative to positive, so it's going to be positive 12 volts. Then from there I2 is in series connection, and there's a series connection of the internal resistance and 28 ohms, so we should add them and we multiply that with I2, and since I2 and our direction are in the same direction, so there will be a voltage drop, so there's a negative sign. Then for I1, 12 ohms are or the internal resistance, and this 22 ohms, they're in series connection. So we add them all together and we multiply them with I1, and since I1 is in the direction uh, of our desired direction, so we put a negative sign because there's a voltage drop again, and we set that equal to 0. So that concludes our loop rule on top loop. And for the bottom loop, we set our direction clockwise. And again, if we start from the middle battery, we see that it's 12 volts to start and it's positive. Then it will be negative for I2 because they're in the same direction again. And since it's a series connection, so 28 plus I. Then for I3, we see that the direction is opposite to each other. So that's why it will be a voltage gain. So that's a positive sign, and since 16R and 11 are in series connection, so we add them all together. And for the battery at the bottom, we see it goes from positive to negative, so that means there's a voltage drop again, so that's why there's a negative sign. So that gives us the loop rule for the bottom loop. So now we have three equations and three unknowns, so all we have to do is solve for I1, I2, and I3. So I already did the calculation here. So if you can see, what I did was I simplified the second and third equation. So this is loop rule for top and this is loop rule for bottom, and this one is the junction rule. Okay, so what we first do is we substitute I1 from this equation to the second one, and the reason we do that is because we want to compare this equation with the third equation, which is dependent on I2 and I3. So we need this equation to be dependent on I2 and I3. So now from the third equation we write I2 in terms of the other terms and substitute I2 back to the second equation. And if we do so, we see that the only unknown we have is I3. So, and if we solve for I3, it's going to be 0.112 amps. And then from there, if we substitute I3 back into the third equation, we'll get I2, and the value of I2 is 0.3146 amps. Now, if we know I2 and I3, it's straightforward. We just put these two numbers in our first equation, and then we'll get I1 from there. And I1 comes out to be 0.426 amps. Right, so that finishes part 1, where we had to determine the current. Now for part B, where we need to find the terminal voltage for the 6 volt battery, what we do is we go from left to right for this case. So we consider this battery with internal resistance system, and we go from left to right. So if we go from left to right, we see there's a voltage gain because it goes from negative to positive. And since there's a voltage gain, so that's going to be positive 6 volts. Then for this part, for the internal resistance, I3 and our direction are in the same, follows the same direction. So that's why there's a negative sign. So it's going to be minus I3 times the internal resistance, which is 1 ohms. And from there, if we already solved for I3 here, so it's going to be 6 volts minus I3 was 0.115. Let me check. No, sorry, 0.112 amps. And since it's 1, so it doesn't matter. And let's see. Okay, let's just write that. Times 1.0 ohms. And that's going to be volts. So the final answer that we get here is going to be 6 minus 0.112, and which gives us our voltage as 5.888 volts. So that's our terminal voltage. Thank you.